Oh, this video will be about interest and compounding more frequently than once per year. So we'll have effective interest rate and even up to continuous compounding. So here we have compounding interest more frequently than once per year. That's our topic for today. And we have an APR, annual percentage rate, equals stated interest rate equals nominal interest rate. That's all the same thing, right? And it's designated by the letter R. That's fine if you're talking about a whole year for the interest rate, but it disregards the effects of compounding interest more frequently than once per year. Just using the annual rate disregards that compounding effect, which we know is very powerful. So let's look at an example right here, and then I'll show you how to translate from annual percentage rate, stated or nominal rate, over to an effective interest rate. There's a couple of steps that we need to do. Let's look at a teeny little example so you see kind of what we're doing. APR is 18%. That's our letter. We'll give that an R. And it's compounded monthly. So we can't use it just as the 18%. We need to turn that into an equivalent monthly rate of interest. So you just take the 18%, divide it by number of months in a year. It's compounded monthly, so we have 12 months in a year. So it equals 0.015 on the calculator, or 1.5% interest per month. And that's what we will be using then in our problems. If interest is compounded monthly, we have to make sure that we have our interest rate on a monthly basis as well. R over M is going to be something that you'll be using. Remember, R is the annual percentage rate, and M is the number of compounding periods in 1 year. Not the whole life of the project, but in 1 year. N is the total life of the project. M is something different here. So let's just take a quick look so we get this in our notes. Semi-annual compounding would be twice per year, right? 2 compounding periods if it's semi-annual compounding in this scenario. Quarterly, remember a quarter is 3 months long, right? And how many quarters are there in a year? 4. Each one is 3 months long. If the problem gives monthly compounding, we know that there are 12 months in a year. Weekly would be 52 weeks in a year. Daily can be either 360 or 365. And continuous, that's another formula we'll get to in just a minute. All right, so now let's go through an example and find the effective interest rate. I sub E is what stands for effective interest rate. And here's the formula. I sub D, effective interest rate, equals 1 plus R over M to the M, and then minus 1. R is the nominal or stated interest rate. M is the number of compounding periods in 1 year. And R over M is the effective interest rate per interest compounding period. Let's look at an example. We just said we have 18% APR. Maybe it's on your credit card agreement. And interest is compounded monthly, so 18% divided by 12 months is 1.5% interest per month. Let's see what that effective interest rate is on an annual basis. So we'll use this formula right here. I sub E equals 1 plus R is our nominal or stated interest rate. I'll say 0.18 divided by M, the number of compounding periods in 1 year. That's 12 months in 1 year, and then to the exponent of 12, and then you subtract 1. So this equals 1 plus 0.015 to the 12 minus 1. You do that on your calculator, you get an answer 0.1956, which equals 19.56% annual effective interest rate. So even though your credit card agreement says you're paying 18% annual interest, they're really charging you, you're actually paying 19.56% annual effective interest rate. Okay, let's do another quick example. If 10% annual percentage rate is compounded daily, what is the effective annual interest rate? Here's our formula, I sub E, 1 plus R to the M minus 1. Let's fill in the terms. Effective interest rate here is 1 plus R is our 10% stated annual rate. So I'll put that as 0.10. M is the number of compounding periods per year. This is compounded daily, so let's use 360 compounding periods in 1 year. Let's use 365 days in a year, and that will turn out to be 0.1052 or 10.52% annual effective interest rate. So even though you think you're paying 10%, you're really paying 10.5%. Maybe not a big deal. You say that's not much difference, but when you compound that for 20 years on a large balance, it can turn out to be quite a few dollars. Another example, say the annual interest on a 5-year CD is 6%. And if it doesn't say anything more, assume that that is annual interest rate. If it doesn't tell you that it's compounded any more frequently, assume that it's annual. Interest is compounded on a quarterly basis. What is the effective annual interest rate? And what will be the ending balance in this CD account after 5 years? All right, so we know that we are given here an annual interest rate, and that will be R. And we know that interest is compounded quarterly, and there's 4 quarters in a year. We know that will be M. What is the effective annual interest rate? So we'll be using, again, our magic formula right up here. Quarterly compounding, let's think about that for just a minute. How many months are in a quarter? 3. How many quarters are in a year? 4. And how many years in this particular problem? 5 years for the investment. So 4 quarters times 5 years equals 20 compounding periods in the entire life of this investment. Now let's go to I sub E equals R over M. 6% interest, annual interest, divided by 4 quarters equals a quarterly interest rate of 1.5%. That's the interest rate per period for 20 compounding periods in that entire 5-year CD project investment. Okay, so that answered the first part of the question. What is the effective annual interest rate? And we know so far that the effective interest rate per quarter is 1.5%, right? We figured that out per quarter, 6% divided by 4 quarters in a year. So 1.5% interest per quarter. Let's use the rest of this equation here to figure out what the effective annual interest rate is, and then we'll go ahead and answer question 2, the present value. So here, I sub E equals 1 plus, now R to the M, R divided by M, we just figured out is 1.5%, and to the 20 compounding periods, right, 4 quarters times 5 years minus 1, and that would give you the annual effective interest. All right, so we just figured out that we have 1.5% effective interest per 1.5% interest per quarter, right? Let's just pause right there for a minute and go to question 2 because I want to show you a shortcut. We can get right to the ending balance. Future value equals present value times the factor from an interest table, right? And so I forgot, you needed to know a beginning balance to this CD that we're putting in at the bank. Let's say the beginning balance of the present value is $1,000. So P equals 1,000 times a functional notation here in the FP column at 0, well, as we could say 1.5% on that interest table for 20 compounding periods, right? So right here is where you need to be sure that you're on the same basis. The interest rate needs to be on a quarterly basis, and then you need to have the number of periods of quarters that there are in this CD. So make sure that the interest rate and how you're measuring the interest periods is on the same basis. All right. Then we can look up the factor from the interest table, and we have 1,000 times that interest factor.
We have to go to the 1 point.
Is 1.3469. And so the ending balance, the future value in that account would be $1,347. Let's say, let's just round it to that.